We install circuits to try and prevent electrical faults from occurring. That's the first priority. But of course, in our imperfect human world, things do go wrong and we need to try and minimize the effects of an electrical fault. But as Chinese military general Sun Tzu stated in his book, The Art of War, first you must know your enemy. So what are the faults that can occur in an electrical circuit? Just before we answer that, if you're watching this on any of our social media platforms, then click the link to watch it as part of our free training package. You'll get a certificate and it'll count towards your annual CPD requirement. If you're already watching it as part of that package, you make good life choices. Let's get into it. There's a number of different types of fault that can occur. The ones we'll consider in this video can be grouped under the heading of overcurrent. As the name would suggest, it's a situation where too much current is flowing into a circuit and there's a danger that it will cause a conductor to overheat, melt the insulation covering it, leading to a shock risk and ultimately possibly start a fire. So how does overcurrent occur? Well, it breaks down into two further fault types. These are overload and faults of negligible impedance. You could probably figure out what overload means from the word itself. It's a situation where there is literally too much load connected to a circuit. Now, for many circuits, this type of fault is not actually a risk. Take a lighting circuit in an office, a classroom, or a workshop, for example. The designer will have looked at the specific lights being installed, calculated the current that will flow when they're all turned on, and selected the appropriate cable and protective device. As all the lights are fixed and might reasonably be expected to be in use at the same time, this type of circuit is never likely to get overloaded. It might happen if someone came along and extended the circuit without doing the proper calculations, but then it strayed away from the original design. The circuits that are more likely to be at risk here are ones where loads can be added by people without electrical knowledge. A good example is a socket circuit. Let's say there's a cold snap and someone starts connecting loads of electric heaters to stay toasty. It may well get to the point where the number of heaters connected causes so much current to flow that the conductors feeding the sockets will start to overheat, leading to the problems already mentioned. The circuit has too much load connected. It is literally overloaded. The other common way that an overload can occur is when the load is a motor. Rather than just drawing a constant flow of current through itself, a motor will draw more current the harder it has to work. So, for example, if you have a motor driving a conveyor belt, it will draw a certain amount of current to keep that belt moving. But if you start to place more and more weight onto that conveyor belt, the motor will have to work harder and harder to keep the belt moving, and to do that, it will draw more and more current. And if you put too much load on the belt, the motor will draw too much current and damage itself. That's what causes a motor to burn out. Too much current flows through the winding and melts the insulation, leading to that all too familiar fishy smell and smoke coming out of the motor. Of course, this can happen on handheld tools as well. If you're asking a drill to drill holes that are too big or run it for too long under pressure, it too will overload and burn out. So that's one kind of overcurrent. What about the other kind, the fault of negligible impedance? This sounds complicated, but we can break that expression down really easily. Negligible just means very, very small, and impedance is total opposition to current flow in an AC circuit. I'll get pilloried by pedants in the comments for saying this, but if it helps, just think of it as sort of very low resistance in a circuit. So a fault of negligible impedance sort of means a fault of very low resistance. When do these occur? Well, a fault of negligible impedance breaks down into two further categories. These are short circuit and earth fault. When we connect up a load using a line and a neutral, we create a circuit for the current to flow through. If for some reason the line and neutral touch each other, maybe through some damaged insulation, the circuit becomes, electrically speaking, shorter than it should be. In other words, the opposition to the current flow in the circuit gets incredibly small. A small resistance equals a large current, and so a huge amount of current flows when this type of fault occurs. It's worth noting that the exact same thing happens in a three-phase circuit if the line and neutral come into contact with each other, and if two line conductors come into contact with each other. This second event, of course, will lead to even higher fault currents flowing because the voltage is that much higher between phases. The other fault of negligible impedance that we come across is earth fault, as its name suggests. This is what occurs when the line and earthing system come into contact with each other. This can occur when a line touches a circuit protective conductor, or if a line conductor touches an exposed conductive part. Either way, this creates a similar issue to a short circuit. The opposition to current flow becomes extremely low, and therefore the current will be extremely high. There is one more type of fault that occurs, and it falls outside this idea of overcurrent, and that is a fault of high impedance. This is what occurs when a person gets connected across the conductors of a live circuit. As the human body has a relatively high resistance, if you get a shock from a 230 volt AC circuit, the current that flows through you will usually be relatively low. Unfortunately, it only takes a tiny amount of current to kill a person. The threshold is usually taken to be just 50 milliamps across the heart, causing causing ventricular fibrillation or a heart attack. If you get a shock between live conductors, such as line to neutral or line to line in a three-phase, there is not a device on the planet that will detect that and cut the supply off. An increase in current in a circuit of a few milliamps is simply not enough to trigger a fuse or a circuit breaker. Ah, I hear you cry. What about an RCD? An RCD will certainly protect you in the event that you get a shock from line to earth. It's set up to detect an imbalance in current between line and neutral, and if it's rated at 30 milliamps, it will disconnect if any more than that amount of current flows through a human to earth, keeping you below the lethal threshold for current. Happily, the vast majority of electric shocks do occur to earth, and so an RCD does offer good protection against this risk. However, it is not a substitute for understanding the risks involved with electricity and good safety practice when working with it. So there we go. Those are our different kinds of electrical fault. If you're watching on our training platform, then answer the multiple choice questions that follow and move on to the next video. If you're watching on one of our social media channels, then click the link to move over to the free training package and get yourself a certificate, or you can watch the same video in the series right here, where we take a closer look at an MCB and all the symbols on the front of it. All that remains in this video is to say thank you very much for watching.